Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 41. And this episode is all about OpenTelemetry, which is a term that seems to pop up every time I turn around at the moment, and for good reason too. And here to join me today to chat all about it is Martin Thwaites, a developer advocate at Honeycomb. So welcome to the show, Martin. Thank you for joining me.
Well, thank you for having me. It's great to be talking about such a popular term.
I know, I'm definitely quite excited about this one. So could you introduce yourself to the listeners and tell us a bit about what you do?
Yeah, so my name is Martin Thwaites. I go by martin.net on Twitter. I am a developer advocate for a company called Honeycomb. I fairly recently joined them, but I've been involved in the observability and the whole sort of logging metrics community for the last sort of 5 or 6 years. And that's generally what I like to rant about on stage, and will wax lyrical to anybody about who will hear me, like yourself.
Yeah, as I said before, I'm really looking forward to this, just digging into OpenTelemetry, observability, especially all the tooling around it as well, which I'm guessing your Honeycomb is going to play into that as well. But before we dig into that, I'm just going to quickly do this episode's listener mention. And this one goes to Tim DeShriver, who tweeted out, "The past month, I've discovered and enjoyed the Unhandled Exception podcast by Drakan during my runs. A great mix for mind and body. I highly recommend it if you want to follow .NET topics, learn new things, and enjoy some chit-chat along the way." So thank you, Tim. And based on what you said, you're probably running right now as you're listening to this. Hopefully you're having a good run, and thank you for your kind comments. And if you want to get mentioned on the show, just send a tweet using hashtag #UnhandledException. All feedback is greatly appreciated, and I'm Drakan on Twitter, which is at DRACAN. And a quick reminder that this podcast is sponsored by Everstack, which is my own company, providing software development and consultation services. For more information, visit everstack.com. And also, very new, just in case you don't already have enough Slack workspaces already, I've created one for the podcast. So basically a place for listeners to hang out and chat about both the episodes and also just software development in general. So to sign up, pop over to the website unhandledexceptionpodcast.com and you'll see a big shiny new Slack link. So hopefully see you in there. So OpenTelemetry. So if we can just assume that, even though, as I said before, you can't really turn around without hearing about it, let's assume that the listeners have maybe never even heard this term OpenTelemetry. Can we just start off by just defining what that actually means?
Yes, absolutely. So OpenTelemetry is an effort to standardize around tracing. Very specifically, that's where it started out. So it all centers around the observability movement, which is a movement around software engineering and the site reliability engineering around observing your systems from the outside. So being able to know how your systems work. And by systems, we're talking about individual systems or distributed systems, but understanding how they're running. Are they healthy? Are they not healthy? And trying to evolve that in a world where we're moving to more distribution, we're moving to more microservices, we're moving to systems that scale down to 0, scale up to thousands. These are all systems that require a different way of thinking than we have in the past. That's the observability movement. And OpenTelemetry is a set of libraries, or more specifically a protocol, that was created to be able to bring together all of these things in a coherent way. So it stems from 2 individual libraries, one called OpenTracing and one called OpenSensors, which were 2 competing projects about 4 or 5 years ago now, where they were providing tracing. And tracing is this idea of taking a request or some kind of trigger and following that through individual systems and individual process boundaries in your applications to be able to say, here's my request into my website. That request caused a request into another system, and that one went into another system. So the idea of a front end and a back end and multiple back ends. And you want to be able to see that particular request and how that made it through into lots and lots of different systems. Now, it was always quite hard. So OpenTelemetry came up with this idea of bringing together open census and open tracing, standardizing around the W3C tracing standards, which is a widely accepted standard, and building a protocol on top of that to make things a lot more vendor agnostic. So it's in a nutshell, OpenTelemetry is a standardized protocol of how things should be transmitted between two services, but also how that data is then transmitted onto vendors, which makes it completely vendor agnostic. What they've done is then layered on top of that the idea of SDKs. So there's SDKs for, I believe, 9 languages now that all standardize around the same approach. And they're very familiar if you're transitioning between languages. And then further on to that, there's initiatives around being able to add things like auto instrumentation. So things that are common in the .NET world. So things like SQL client, being able to say, oh, I'd like to be able to see what queries were run. So they have these auto instrumentations as well. It is going a little bit further now. OpenTelemetry is a really evolving project. It's number 2 on the CNCF's list of projects, so it's getting a lot of attention right now. But yeah, it stems from tracing. It's moving into different signals now, which is the OpenTelemetry terminology for different segments. So we've got the main signal being tracing, then they're now moving into different signals like logs and metrics, which should be GA very soon.
As soon as you started talking about it, in my head just jumped out microservices, that kind of distributed system. And then you actually did use the term microservices. But I guess thinking about lots of modern architecture where the lines blur over to whether you would call something a microservice, because now you tend to get you might get a Spire application, you might get a few APIs and stuff that do different things. That might not be a full-on microservice architecture, but nowadays you tend to have multiple services involved, even in just a normal application. So just having this out-of-the-box standardization just sounds really, really good.
I think what's really interesting there is that from an OpenTelemetry perspective, we talk about process boundaries rather than microservices. So a microservice, as I say to quite a lot of people, unfortunately, there is no IEEE standard. So you can get somebody to come in and stamp your application and say, yes, that is absolutely a microservice. It means a lot of things to a lot of people, which means that we, as a community, we didn't want to get into that debate. So we talk about process boundaries. So we talk about a request that transitions 2 process boundaries. That might be 2 process boundaries on the same machine. It might be 2 process boundaries that exist on 2 different VMs. It might be 2 different containers. It could just be something that happens now and then something that happens in a few days' time because somebody picked something up. But it's also about correlating all of those things together, the things that cause something else to happen.
I'm glad you used the term correlating them, because talking about all this tracing stuff you've been describing, correlation IDs jump to mind, where in the past we might have manually tried to do it, but presumably this whole concept of you've got one service calling another and passing some form of correlation ID or whatever it is across. So then when you're observing and you're looking at the logs and the traces and things, you can just see exactly what happened across an entire, I don't want to say call stack, it's almost like
it's a transaction.
A transaction, yes.
And transaction is the term that we use a lot of the time. And a transaction is now analogous to a trace. So a trace would be, how does this particular initiator, so the HTTP request being your initiator that initiates a trace, how do I trace that through all of the different things that happened in all of the different systems before that thing then returns to the user? So think of it like the idea of a transaction. So a HTTP request being a transaction from request to response, and everything that's entailed within there would be a trace in its own right.
Yeah, that makes total sense. And then, like, if you think about a support team, if they get an exception or something, they can actually see that entire transaction and find out exactly what happened that caused that one exception.
Yeah. And it's, you mentioned correlation, you mentioned logs, and that's something that's existed for, I would imagine, decades, probably way before my time coming into development, but correlating logs has been, a staple for a lot of people. The difference when you move into tracing is that you're actually talking about causality. So it's not saying that a request has 4,000 log entries because it went through 7 systems and all of those 7 systems Each of them produce 300 log lines, but I've got a correlation ID. So I can do the correlation ID and I can work out the times. And I can say, well, this thing happened after this thing. So that probably is the things that happened at the same time. So when you move into tracing, what you're actually doing is you're saying that this thing that I've done was caused by this other thing. So in a HTTP context, to use a specific example, when you've got a HTTP request coming in that then calls a database, and then there's a call after that to a third-party web service, what you can actually see is that the HTTP request caused the SQL statement to be executed. But then it wasn't the SQL statement being executed that caused the web service to be called after it. It was done in parallel, or it was done in series, but it wasn't called by the database. And that is really important when you start to think about these really complex systems, because you want to know that these things happened one after the other, not that they happened at the same time, not that they happened at some point within the request. You want to be able to see those individual things and what caused each one of those to happen, which is where a lot of people, you will say, and this is something that you'll see if you start Googling and you start looking at the OpenTelemetry docs, you'll see something called a trace waterfall, which is the idea of a individual transaction, this trace that we were talking about, where each of the things that happen, they have blocks. You may get sort of flashbacks to Microsoft Project because it does look a little bit like a Gantt chart, but trust me, it's not. It's actually useful. So you'll see this trace waterfall, and you'll see a HTTP request, and you'll be able to see each of the spans within there, which is what we call those individual segments within there. And it starts to provide you with a really good picture of what's causing a request to either be slow, what's causing a request to have thrown an exception, for instance. So it might throw an exception right up at the top, but what you actually want to see is that it was this third-party web service that caused that exception to happen, and everything else worked fine. And you can see that at a glance from looking at things like a trace waterfall.
So this sounds like such a complicated problem if you were trying to solve it yourself, which actually screams out why something like OpenTelemetry is so valuable. Presumably, like for where you're talking about the observability and having tooling to view that information, presumably because OpenTelemetry is a standard, then you can use many different observability tools and you can basically pick and choose, and it would all just plug into the same data. Is that correct?
So that's exactly what OpenTelemetry is built to do. It's built to be 100% vendor agnostic. It's not built by Honeycomb. It's not built by any of the other providers. It is built by the community. Yes, there's a lot of us from the observability community that work for companies that provide observability products that are helping to build this OpenTelemetry as a library. But the idea is that it's completely vendor agnostic. You will implement into your code base OpenTelemetry. You'll then decide later as to where you will send all of those signals to. You can even decide that actually I want to send my tracing data to one provider, I want to send my metrics data to another provider, and I want to provide my logging data to another provider. That idea of being 100% vendor agnostic is one of the founding principles of OpenTelemetry, is that we don't want it to be a lock-in at a vendor level because you've installed some things that are very specific to that particular vendor. We want to make it so that you can choose, and it's up to the vendors to be better than the other vendors, not by choosing lock-in. And it's one of the founding principles around Honeycomb, is that we are the best in a particular area. So we push back into OpenTelemetry, and we don't really have our own SDK, for instance. We use the OpenTelemetry SDK. You install the OpenTelemetry SDK, you put our URL in the exporter and send us the data, and it will then be visualized in there. There's also open source products that you can use, especially if you're running locally. It's really useful to be able to run some of the open source products just to get some of those trace profiles in a very, very quick way.
It's funny you mentioned about locally, because that was actually coincidentally my next question. Like quite often, like for example, if I'm doing something with messaging, I would use like in production something like Azure Service Bus, but locally I would use RabbitMQ because I use an abstraction library, and I use Docker very heavily, being able to spin up all my local stuff, like whether it's a database, whether it's RabbitMQ, and presumably because all this is using this OpenTelemetry standard, and as you mentioned, there's open source tooling that you can then, just as part of your Docker Compose up, you can spin up tools to visualize your OpenTelemetry data as well, just as part of that local development experience?
Absolutely. Jaeger is a very popular tool for doing that, and it has a Docker image that you can use to do that. What we found is that running stuff at scale in production is a very specific problem. So trying to run Jaeger at scale in production is not a pleasant experience, shall we say. Not that it's not doable, but the amount of resources you sink into being able to do that. It's the same as running something like InfluxDB in the cloud and trying to scale that. It's quite hard to do because it has some certain restrictions on there. And we always recommend that if you're moving into production, you want to be able to visualize vast amounts of data very, very quickly, then push it to a cloud provider that's built a data store that's specifically suited to that particular need. But obviously running locally is a bit of a problem. It's something that I'm personally invested in doing, is trying to work out what our local developer experience looks like for tracing. I'm on a mission to remove logs from all applications and replace them with traces. But in order to do that, we need to improve the utility of traces so that you get the same level of visibility out of traces locally as you do from logs locally. Because then you get the byproduct that the traces that you've just built for your local visibility, you're going to get in your production visibility as well, which is when we get to this idea of observing production systems, that ability to say, what's going wrong? And if I've been able to debug that locally, I should now be able to debug that in production as well.
Yeah, totally. I think it also helps developers understand it if they can just play around locally without fear of damaging any production data or anything. It's just a local thing, Docker Compose up, play around to your heart's content, and then it just helps developers just understand it better.
Actually, what I want to do is I want to go a level further than that. I don't even want people using Docker. I want people to be able to say locally, I've got a console output, and I use my console output to look at my logs at the moment, as a lot of people do, and especially the people who are running in the modern ways with .NET. So they're not running Visual Studio, they're running things like VS Code, and they're used to the terminal now. They can see the log output from a terminal, and they use that log output to be able to see what's going on. I want that same level of visibility of traces in those sort of environments. Not I need to do a Docker Compose up. Because Docker Compose up is great. You can bring up lots and lots of stuff. And I talked about being in this sort of observability community for the last sort of 5 years. And that's how I started out. I used to use Docker Compose to bring up an InfluxDB, to bring up a cluster to be able to send my logging data to. I used to do that, but it was running something on your machine. It uses CPU cycles. And if your PC isn't that great in terms of performance, it causes a problem trying to run all these things. So what I'm trying to do personally is look at how we can bring that into that local developer experience so that people don't go, oh, I need to do a Docker Compose up and run another website to be able to see all this stuff. I'll just use logs. It's easier. This whole idea is about how do we make the right thing the easy thing? So if looking at traces is the right thing, let's make that easy for developers to do. My mission is to bring tracing to developers, to make sure that developers are the ones that go, I need tracing because I care about my production systems. And I think that's a message that I'm trying to push in the community at the moment, is that developers need to care about production. The whole DevOps movement was around developers and operations getting closer together, developers caring about production, ops caring about development, and working together to do it. And I think that's core to this idea of us saying, great, we've got tracing. How can I use that? How can I know that my code is actually running in production?
Yeah, totally. And I think with the local development store, it's all about giving the developer choice. So like for those developers that want to use VS Code and just see output in the command line, they can do. For those developers that want to actually have a web portal, like whether it's Jaeger or whatever, so they can actually get the full experience. And it's just different developers like to work in different ways, and it's giving everyone the right choice. So before you mention about these OpenTelemetry SDKs, who would actually be using those SDKs? Is that for, like for example, I'm a .NET developer. Am I, as a developer, using those SDKs, or is that something that Microsoft's using as part of .NET? As a Node.js developer, would they be explicitly installing these OpenTelemetry SDKs? I'm just trying to work out who these SDKs are actually targeted for.
So let's just say in the community at the moment, it's fragmented. There are a few different ways that you can extract data, extract traces, metrics from your systems using OpenTelemetry. The main way for .NET developers to do this is about 10 lines of code in your startup, which will initialize it. It will use something called activity in .NET to then observe all of the things that are happening and then convert those into spans and then push those to whatever exporter it is that you've wanted to do. That's the main way. There is a project at the moment within OpenTelemetry called Auto Instrumentation for .NET, which is using the CLR injection to actually inject all of these things at runtime so that you don't even need to do the 10 lines of code to do that, which is a really interesting project that I'm involved in. But the main way for me is doing that idea of just drop some code, 10 lines. It's really hard, drop the 10 lines of code in your startup, job done. Within a lot of the other communities, so specifically Java and Python, there is an agent that you can run. And the agent will wrap your JVM process or your Python interpreter and go, great, I will give you all of this data just for free. Now, to me, this is the difference between auto instrumentation and manual instrumentation, because my feeling is that manual instrumentation is where the magic happens. Manual instrumentation is what you understand about your application and you saying, this thing is interesting to me. You'll say, I've got an algorithm. These 20 lines of code in my this method here, these are really important that we know whether this thing is running particularly well. It can have massive implications. It might be that it changes the performance based on the number of, you pass in an integer into the method. And if it's a 10, then it's going to take 20 seconds. If it's a 5, it's going to take 5 seconds. And that might be really interesting to you. Manual instrumentation is where you say, I'm going to wrap that in a span. And that is where things get really interesting with tracing. Otherwise, all we're really doing is we're looking at the out-of-the-box metrics and the out-of-the-box spans that we get from SQL Client or Redis Client or from ASP.NET, which provide a certain level of utility, but it's not where the magic happens. So to me, the user of these libraries is actually the developers, the engineers. And this is one of the reasons why I've been brought into Honeycomb, is to start this movement of how do we get developers to care about OpenTelemetry? How do we get developers to care about their production systems enough to be implementing OpenTelemetry, to be able to say, I need visibility of these things at a very, very low level.
I see. But it sounds like again, I'm just using .NET because I'm a .NET developer, so that's the platform I'm using. But if I wanted to create my own span or activity, I think they call it, then I would still be using Microsoft's activity class. I wouldn't be using an OpenTelemetry library. That would be happening through Microsoft's activity, I guess.
Okay, so your mannerisms when you were saying that is exactly how everybody's feeling right now about activity. Activity has muddied the waters. There are reasons why, and I've wrote an entire blog post, which I'm sure we can link in the show details, about where activity comes from and why it's a little bit different and that kind of stuff. But yeah, the activity is something that Microsoft is analogous to a span, whereas an activity source, which is what an activity is created from, is analogous to a tracer in OpenTelemetry. So yes, you would use those. You can use the OpenTelemetry shim, which has been created to give you that same idea of tracers and spans so that you've got consistent terminology. Under the hood, it's just creating activities. So that's more about syntactic sugar on top of your the stuff that you're doing. But yes, you would create a activity, and that activity would run for a particular length of time, and you would add attributes to it or tags in .NET. And then that thing would be then observed by OpenTelemetry. So OpenTelemetry then listens to activity sources. Under the hood, what it's really doing is creating an activity listener. And that activity listener is then listening to certain sources. And then whatever sources are then producing activities, it will then convert those into spans. And then it will send those to whatever exporters you've configured. Very, very complicated. And it's hopefully something that people don't really need to care about. And that's what we're trying to do, is abstract them away from this idea that you actually need to know what an activity source is, what an activity listener is. You need to know how to convert that into a tool that somebody else uses. And we've not, as a .NET community, done really well with this before. As a .NET community, what we've done is push things to vendors, and we've installed a library that's very specific to an individual vendor. And unfortunately, that gives you a lot of lock-in. You can't easily move vendors if there is somebody else who's doing something in a particular space that's better. This is hopefully going to allow people to be able to say, I'm just using OpenTelemetry. Oh, look, there's a better provider of X. We will start sending that data to them. My hope, beyond hope, is that this keeps vendors honest. It keeps vendors innovating. It keeps vendors from getting complacent, because you actually need to be continually the best, because it's easy for people to move, but it's also easy for people to send it to multiple sources. And that's a really interesting thing within OpenTelemetry, because within OpenTelemetry, you can actually configure multiple exporters for the same signal. So you can say, for my traces, I would like to send them to Jaeger locally. I'd like to write them to a file. I'd also like to send them to vendor X, Y, and Z. And what we've seen specifically within Honeycomb is people actually using that as the equivalent of the Great British Bake Off of vendors. We'll send it to all of them and see which one does best. It's the technical challenge of the Great British OpenTelemetry. So how do we then take that to all of these vendors and say, well, we've got some traces. Who's going to provide us with the best level of visibility? Because all of the vendors do something a little bit different. For Honeycomb, for instance, we focus on high cardinality, high dimensionality, high performance, and significant load. Those are the things that we really focus on. We've got other things that are coming, but that's our niche. That's where we've built our brand around, being able to say, send us as many attributes as you want on every one of your spans, and we'll be able to do great things with it. There are other vendors who focus on different things, like service mapping, for instance, which is a very specific idea, which is a different thing that you might want to send all of your traces to them to be able to say, let's do some really fancy service maps. Let's do some really fancy things in different areas. And that's a really interesting thing that I don't think we push as much in the OpenTelemetry community, the ability to do multiple exporters so that you can either use them for different things, or you could do a trade-off and say, right, which one's right for us?
I definitely like that idea of getting different vendors to actually... It's like with the cloud platforms now as well, with Azure, AWS, Google Cloud, where they've got to compete. Otherwise, they're going to just lose all their customers to another one, like with all these new services, whatever they are. And also another thing I like about Kubernetes as well, that makes it so much easier for each of the cloud providers to have their own Kubernetes thing. But it's quite easy to take my architecture and put it on someone else's if I'm not happy with AKS, for example, or the way Microsoft do it. I can easily swap it over. And it sounds like it's very similar here. And also you touched on earlier about sometimes you might want to send different types of telemetry to different places, maybe logs to one place and traces to another place. So it just feels like this, again, going back to this choice.
Yeah. The OpenTelemetry term is signals. So we call them signals. So traces is a signal, logs is a signal, and metrics are a signal as well.
Yes, I see. That makes sense. So just so I understand this SDK thing again, and I'll keep on going back to it, but if we move away from .NET then and look at another language like, I don't know, Go or Node, when I'm using spans there, am I directly using the open source telemetry SDKs in that case?
Okay, so .NET is unique. And the reason that .NET is unique is because we already had this kind of stuff, so ETW and all of those things in the past, they already existed. So .NET is very much about backwards compatibility, which is why that exists in that particular world. We also, as a community of .NET people, which I don't like, we don't like taking dependencies on third-party libraries, especially as part of core dependencies. So .NET is unique in that way. The rest of the community are not doing that. They are using OpenTelemetry directly in a lot of their libraries. The Go community has welcomed this with open arms. JavaScript it works, but there is still some nuances with the way that works. Java is very much on the auto-instrumentation bandwagon, so they're very much reliant on the agent to inject a lot of these things, but it is still using OpenTelemetry directly rather than bringing in sort of BCL type stuff. I think it's really because .NET we're reliant so much on the BCL. So the base class library that is produced by Microsoft, which has all of those bits of functionality in it. Whether that's a good thing or a bad thing is open to debate, and that's probably an entirely separate podcast. But that, I think, is where .NET comes from, is that we don't want to take those dependencies. In my blog post about this, I talk about, for me, use activity directly if you're writing a library, something that's going to be used by other people, even if it's an inner source type project where it's even people inside of your organization. Use something like activity because it leaves things a little bit more open and means you're not bringing in that dependency. If you're writing an application from scratch, use OpenTelemetry. If you're writing an actual application that does something, use OpenTelemetry, because that's going to allow you things like baggage, a lot of the other concepts that are existing within the OpenTelemetry SDKs, so the auto-instrumentation and things like that. Use those things. Whether you should use tracers inside of your application or whether you should use activity is a personal choice thing. For me, the reason to do it is if you're a polyglot developer that's jumping between lots and lots of different systems in lots and lots of different languages, it could make sense to just use the OpenTelemetry shim so that you're jumping between them going, oh yeah, tracer.create span, tracer.create span, tracer.create span in all of those different languages, and it might help with that idea. But if you're really just writing .NET applications, activity is good enough, and you can add as many attributes, you can do all of the things that you need to be able to do.
Yeah, that makes total sense. I think my confusion was where I started reading about OpenTelemetry and they were talking about all these SDKs and everything. And I was thinking, well, I'm kind of using OpenTelemetry, but I've never seen these. So I got confused about who actually uses it. But as you say, if kind of .NET is slightly different and with other languages, you would be using those SDKs, then that makes total sense.
Yeah, the SDK for Microsoft, for .NET, is really about your startup class. It's really about using services.add-OpenTelemetry, configuring what things you want to monitor, and then configuring where you want to send that data. So saying, I would like to monitor SQL client, and I'd like to see the command text, I'd like to see the connection times, I'd like to see X, Y, and Z, and then choosing where you want to send that particular bit of data. So do you want to send all of your SQL data to one source and all your other data to another source?
I see. So you used the term baggage before, and just in case the listeners don't know what that means, am I right that that's pretty much a key value pair that persists across an entire trace or transaction?
Okay, so baggage, as I've wrote an entire blog post on this because baggage is the foot gun you never wanted, was the title of the article. So it's very much a concept that people misuse and misunderstand. Baggage is a W3C standard that is the idea of transmitting additional data between your process boundaries. So we talked about this idea of microservices being one type of process boundary, or even just using different services, using service-oriented. It doesn't have to be a microservice, but transitioning process boundaries. Now, what you might want to do when you transition between those service boundaries is send additional data that would allow you to then manage what happens in that other service. Now, what people see is that baggage is just the equivalent of a span attribute that transitions over every single span in your entire process. That isn't what baggage is done. It's what a lot of people use it for. I'll be honest, and even Honeycomb have perpetuated this idea by creating a span processor that just takes baggage and adds it to every one of the spans seamlessly, which is not the right idea in my opinion, but it is what's been created. Baggage is incredibly dangerous because all baggage is a list of strings. It's a key value pair string of string, which means that you can send any data you want. It also sends it on every single process boundary change. So that means every single HTTP request that your application makes will provide all of that baggage. Now, if you imagine, the problem with that could be, well, what if I put a user's first name on there because I actually want the first name to be available in that second system? That sounds like a reasonable thing to do if you've got two services that you want to do. Now, what happens if then that first service also decides that it needs to call out to a third-party service to get some other data? Well, that's transitioning a process boundary because that third-party service is another process boundary, which means that now your third-party service has got the first name of every single one of your users that's been hitting your system. So now you've got a data leakage problem. That's problem one, and hopefully we're trying to make that a little bit better. Problem two becomes that it's just a string. And we all know that developers love to abuse systems. And I have literally seen somebody go, oh, I need this object in this other system. So what I'm going to do is I'm going to do JSON serializer.serialize object into baggage. And all of a sudden now, all of our HTTP requests have now got an extra 500 kilobytes of data that has been transmitted between them, just so that somebody can deserialize it on the other end. Now, it's not the wrong usage of baggage, because baggage is just a string. But it does mean it's dangerous. And it does mean that it will be misused. So to me, never use baggage. But if you are going to use it, be really specific about why and be really cautious about where that's going to be sent.
Yeah, I totally see what you mean. It's like the example you said where it gets sent to one place, but then also you might not realize it's also being sent to another place, which might be a third-party provider, and you might have really sensitive information, maybe way more sensitive than first name.
Yep.
Yeah, it's a very good point. So I think it's important that people understand what they're doing when they're using this stuff and how it works. And it's probably important anyway, because as you said earlier, developers really should own a feature and changes to production. So they kind of need to understand how to observe it as well. So they kind of need to understand this stuff anyway. But it sounds like all this makes things so much easier than if you were trying to do this kind of stuff yourself.
Yeah, I think the biggest win with OpenTelemetry is the cross-platform nature of it. It's the idea that if I want to send a trace and I'm in a polyglot environment where some things are going to Go services, some things are running Python, some things are running .NET, then I don't need to think about how does one system communicate with another system its telemetry data. How do I make sure that, well, if I want to use Honeycomb, how do I make sure that I can use that in Java, I can use that in .NET, I can use that in Go? Well, because we're using a protocol for this, you don't need to worry. As long as there is an implementation of OpenTelemetry inside of that language, then you can send your telemetry data to any of the services that accept OpenTelemetry line protocol data, or OTLP. As long as they accept that, then you're golden. But it also means that if I want to use something called, so let's step back a little bit, because I think I did miss the idea of something called propagation. So the idea that if I'm running a trace from my top end service, my front end, my SPA app with its BFF in the front of there, which is going to create our initial trace, how do I get that data into the next service down, which is calling into an API? And that's something called propagation. So the idea that I'm going to send over my trace ID, in the olden days, that would have been correlation ID. It's now used the term trace ID. I would send over that. I would also send over what my parent span was. And that's where we get that causality. So it's this specific process in this specific system is the thing that caused us to call this other system. And that's all called propagation. And it's also where baggage comes in as well, where we'll use that propagation system to propagate that baggage over all of those different services. That protocol is a W3C standard, and all of the OpenTelemetry SDKs that you will install in your applications are compliant with that methodology. So again, this idea of it being cross-platform means that, well, yeah, I could absolutely write something in every one of my applications that inspects the headers and says, oh, yes, I'm using foobar for my trace ID field. So, I write something in every one of my... You just don't want to do that. You want to just install an SDK and know that all of that trace propagation is all going to just work out of the box. And that is simplifying so much of our industry when we talk about using microservices, when we talk about being polyglot, when we talk about using the right tools for the right job. So Python might be the right job for the thing that you're writing. Well, just use that. It supports OpenTelemetry, so you're not going to lose any of your production visibility by choosing a different language.
And you get that trace right through the system regardless of what the service is. Yeah, that really makes sense. So you've used the term agents quite a few times before. And if I just think of a typical service running on its own, where it might be, let's think of one example where it might be pushing logs or something to a third-party service. I drop an application insights, for example. Or I know I've worked on systems where, say, a Kubernetes environment where we've got something like Prometheus installed, which is scraping against an endpoint on my API to get the metrics from there. And then Prometheus is like a data store, which something like Grafana might visualize that data. This term agents in this context, if we look at the bigger picture, what does an agent look like and where does that sit?
Okay, so there's a slightly different concept. We'll talk about agents, and then we'll talk about something called the collector, which is a slightly different concept. Agents are about things that sit alongside your application, or they wrap the startup of your application and inject stuff into your application for auto-instrumentation purposes. The reason why they're really useful is if you don't have the ability to change the code, to add in the SDK, to add those 10 lines of code that we were talking about from the .NET environment. If you don't have the ability to do that because maybe it's not your application, or if you're running in a mode where you've got a separate dev and ops team and your ops team run the application, it might be that the ops team still want tracing data, but they don't have the ability to change the code because the dev team are the ones that control the code. Agents come in that scenario where they will inject into your process the ability to extract that data. So to be able to say, in the .NET world, it will inject into the CLR the ability, some IL, essentially, that says, extract all of these activity sources for me and send them to this location. That's where agents come in, because it's really interesting in that scenario to be able to say, I don't want to change the code, but I do want to get that level of visibility to see what SQL queries it's doing, what amount of time is it spending in serialization in the ASP.NET frameworks.
So where would that sit in? Is that part of your build pipeline? Is that just an extra step after compilation? Or is that something that's, I'm just trying to visualize where that actually sits.
Yeah, so that's an executable that is done at runtime. So that's something that you would do actually at when you're running your application. So think about this. If you threw over your application over the wall, so let's imagine that we're in the 80s and you write your application and you throw it over the wall and somebody else will deploy your application. It's the people who would deploy their application would say, right, I'm going to run it, and then I'm going to attach to that application X, Y, and Z profilers. So think of it like the profiler that you would attach to your application when it's running.
So like in a Kubernetes environment, for example, would that be a sidecar container or would that be something actually having to sit inside my container?
It would actually sit inside of your container because it's a process that needs to have access directly to the process.
I see.
To do that. So in the sort of APM world within .NET, and obviously we're both .NET developers. The clue's in my Twitter handle, Martin.net. So in the APM scenario for .NET, what you would generally have done if you were running full framework is you would run an application alongside your main application, which would inject into the app domain, and it would inject to maybe do a wrapping of each one of the methods to be able to extract some data out. That's the agent scenario. So you don't make changes to your code, but you still get that same level of visibility out. Now, the second concept is something called the collector. Now, when we talk about an agent, we're talking about extracting that data from your application. Now, extracting data from an application could have memory implications. It could have performance implications, especially if you're trying to do things in a synchronous way, where you're actually dependent on now your third-party telemetry provider to respond quickly enough to be able to say that your request can finish. Or if you're using a batching process, it could be your third-party provider has been down for the last hour. So your application is now backed up with 1 billion different telemetry calls that it needs to send that data off. And now we've got a memory issue inside of that application. But all of that's happening inside of that process. And now we've got a problem that we're going to have to drop some events. Now, what OpenTelemetry have done is creating something called the OpenTelemetry collector. Now, the collector is a service that you can run inside of your infrastructure. You can run it as a sidecar in Kubernetes. You could run it as its own pod entirely in Kubernetes. You could run it inside of ECS, for instance, in Amazon, or inside of container apps in Azure. I'm sure there's something that you can do in that Google thing that they do, that cloud. I believe they've got a cloud. I don't really know it, but
who's Google?
I don't know. Some search system, I think. A bit like Lucene, I think. But yeah, they would have inside of that environment, you would have a collector. the collector can receive all of your spans in real time and then can distribute those to your third-party providers. So it works as a kind of internal cache or an internal proxy. It can be really good from a security perspective, because if you're talking about a really hyper-secure environment where, let's just use Kubernetes as the example here, where you've got lots and lots of pods and you don't want any of those pods to have external connectivity to the internet, but you do want to send telemetry data. One of the really cool things about the collector is, well, you can run your collector inside of that environment. You can have all of your pods pushing their telemetry data to that one collector instance. And you can actually use that one collector instance to then push all of those logs out to one source, which means you can limit your egress. You can limit where things can go just to that particular collector, which makes things really cool. You can also use service meshes and stuff like that to have the locations. Becomes a really scalable environment inside of Kubernetes to say, I only want my telemetry data going to one particular source. It's also really cool if you don't want all of your applications to have your API keys to all of your telemetry providers, because you can just centralize those inside the collector.
I see. Could you say that the collector is almost like a buffer for your telemetry data, or does it keep, as in, presumably that's got to then purge data as it's pushing it out?
Yeah, so it does a couple of things. There are what's called pipelining or processors, so that you can, as your traces come in, you can enrich them. So in a Kubernetes world, one of the really cool things it does is it will actually enhance the span data with your pod ID, with the namespace that exists in. It can also do things like redactions. So it can say, you sent me over a load of stuff, but on here it's got the person's national insurance number because we're in the UK. If we want to internationalize this, social security number for the people in the US, which is really, really sensitive data. What you can actually do is you can say, you know what, inside of my centralized collector process, I'd like to remove or redact all of those social security numbers or national insurance numbers from that data. So it provides more than just it being a buffer. It is a pass-through. So it should take those spans in and then send them straight back out again once it's run through its processing stuff. It can also do, there is a tail-based sampler, but we don't recommend people use it. So that's the idea of sampling data to say, I only want one of these to come through, but I want one of them, but tell them there was 1,000 of them. So that's the idea of sampling that data. It can do those. It's not a great experience inside the collector at the moment. It doesn't work particularly well, but I mention it because it is mentioned in the OpenTelemetry docs. So just be careful with that and look into what it does.
It sounds so powerful. So you mentioned service meshes before. I'm kind of thinking, like, for example, take one service mesh, Linkerd. If I install Linkerd, it installs like Prometheus, Grafana, or anything. Is there any work going on with service mesh providers? Like, I think you've got SDO, Linkerd, Open Service Mesh, and a few others. Is there any work going on with those that when you install a service mesh, you're also getting OpenTelemetry stuff like these collectors as part of it?
The OpenTelemetry collector can actually use Prometheus endpoints to scrape its data. So that's already a thing that it can do. So things like Linkerd that will have a Prometheus scrape endpoint, because it already has those, you can actually use the collector and just point it at your Linkerd instances and it will extract all of that information out. So it will do that discovery and find all of those things. Envoy Proxy has recently announced they've got a PR in now for actually exporting traces via OTLP. So you can actually then configure Envoy Proxy to be able to send that tracing data to a collector and then outbound to other providers. So what we're seeing is a lot of these providers, whether it's the ones that do service meshes, the ones that do metrics and all of that kind of stuff, they're all gravitating towards OpenTelemetry as being that mechanism. They're all gravitating to using the OpenTelemetry line protocol as their export mechanism for their traces, for their metrics, for their logs, so that they can go through a collector and then they can go to whatever sources we need. We don't need proprietary stuff anymore. We don't need to say that we're going to use provider X on day one. One of the things that I used to talk about quite a lot when .NET Core started was the introduction of iLogger. It's one of my favorite things in .NET because I don't know about you, but when we used to start projects maybe 10 years ago, The first 6 months of the project was deciding which logging framework we're going to use. Are we going to use nlog? Are we going to use log4net?
And which IOC container you're going to use as well. So the same thing.
Exactly. And what was really interesting about that was the reason why you had to make that decision is because every piece of code that you wrote to get that visibility, you needed to use that library. Now, when iLogger came along, that killed that debate. It's like, right, we'll just use iLogger and we'll decide where we're going to put the data later, because we don't need to make that decision now. We'll just depend on iLogger. Hopefully, with OpenTelemetry, with the OpenTelemetry line protocol becoming such a big thing, is we can do the same when we talk about traces, when we talk about metrics. Because all we do is say, well, we'll just use OpenTelemetry. We'll decide where we put it later. We'll just use OpenTelemetry and we'll push it to the collector, because then we can push it even further down the line, because it's not until the collector is built and the collector will manage where all those things go. So it's really making engineers more productive by saying you don't need to have those debates right now. It's probably annoying developers because those debates were always really interesting and it delayed us actually doing real work. But it is going to be hopefully a productivity boost now, because everybody's going to be standardized. When you go into a new organization or a new project, you don't need to say, oh, well, I only know how to use log4net. So how do you do this in nlog? Which were all the things we used to have in the past. I mean, now it's just use Serilog, obviously, because everybody uses Serilog. But obviously, we're hoping that then people gravitate towards the same with OpenTelemetry.
Yeah, it sounds that way. As you say, like with the whole dependency injection stuff in .NET, in iLogger, all this kind of stuff, you just don't have to think about it now. It all follows the same pattern. It's quite neat. It was interesting when you mentioned about the announcement for the Envoy proxy. Ironically, the service mesh we've mentioned the most so far, Linkerd, is probably the only service mesh that doesn't use the Envoy proxy. All the other ones use Envoy proxy, but then Linkerd has written their own, a really lightweight, specific proxy. But hopefully they do something as well.
So Linkerd actually does use Jaeger as its mechanism. Within the collector, so one of the really interesting things in the collector is that you have something called receivers. And receivers are where we receive data in. Some of those are push and some of those are pull. So the push ones are obviously our OpenTelemetry line protocol. So our SDKs in our applications or our agents push data into the collector in OpenTelemetry line protocol format. And you set up receivers in the collector to do that. One of the receivers that you can set up is to receive Jaeger tracing data. So Linkerd, the one that you've mentioned quite a lot, would also be able to use the OpenTelemetry proxy, which would then convert them out. My hope is that obviously projects like Linkerd, which are very popular, will move towards the OpenTelemetry line protocol like everyone else, and then we will have a really standardized approach everywhere.
Awesome. I feel like I need to rename this podcast to like a Kubernetes podcast or something. It comes up that often. So going back to the observability side of things, obviously if you've got dashboards where you can go in and view charts and...
Oh, you mentioned the dirty word. You mentioned the dirty word of dashboards.
Oh, no. But something you've actually got to physically go and have a look at. This concept of alerting, does that form part of this story? Or is that something that goes into the tools, the actual vendor tools?
So observability in general is the idea of what can I learn about my system from the outputs that it delivers me. It's based in science. It's a scientific concept of control theory, I believe. But that's where it comes from. When we talk about alerts, triggers, that kind of stuff, they're all based on those signals that you get out of your application. So that's a layer on top of being able to alert when things happen. What I would say on that is that, again, things are evolving. We used to just say, did I get more than 500 errors in the last 10 seconds? Okay, go and get somebody out of bed. The problem is when you're talking about high load systems, it's no longer relevant. Those 500 requests just could be somebody sending us duff data. And it might not be really important to us. There's a movement towards something called service level objectives, which use service level indicators to be able to say, give people budgets. I can have 500 errors every day, and that's perfectly fine. I can have 500 errors providing they're distributed over different users, or I want to be able to say that a certain number of users have been affected before this particular thing is triggered. And what that's doing is helping us in the on-call scenarios of developers to be able to say that we don't want to get somebody out of bed for noisy alerts. Those noisy alerts are the reason why people hate being on call. If you can get rid of noisy alerts, being on call is basically free money when people pay extra for people being on call. So triggers in general are great, but try and augment them with SLOs to be able to say that it's not just X happened, it's that X is going to cause you a problem in the next couple of days. It's this idea of saying to your product owner, if we don't fix this now, in 4 hours, it's going to be a problem. So why don't we fix it now? If we don't fix it now, it's going to be a problem in 5 days. So we should really get something on the backlog and get it sorted right now, because I can tell you that they're going to have a problem. So it's providing the engineering teams with their ability to go back to product owners, to the business, and say, we have an SLO, we have an objective that we've worked together to do. I can tell you that this SLO is going to be breached in the next 5 days. So I really need to sort something now. So that feature that you wanted is going to be delayed a little bit, because otherwise it's probably going to be delayed anyway, because I'm going to be up in the middle of the night sorting this thing. So you're going to lose 2 days of my time.
Yeah, that makes total sense. But again, it kind of sounds like a very complicated problem. It sounds like quite easy to say, but then to actually get all those business rules in to what is an alert that should wake you up in the middle of the night versus, well, you could argue that no alert should wake you up in the middle of the night, in fairness, but how do you actually determine programmatically whether something's important or it's something that can wait? It just sounds like a really complicated problem.
It absolutely is. And this is why I hate the idea of auto instrumentation. I hate the idea of automatic anything. Observability to me is about being purposeful about what it is that you're doing. It's not install agent, go home, and then the ops team can look at some dashboards, because dashboards don't provide you with that level of visibility. To me, observability is about having a conversation with your system, an unscripted conversation where you ask it, how are you doing? Okay, something's going wrong. Well, where? Tell me where. Who hurt you? That's the idea of being able to have that conversation with your system. Auto instrumentation doesn't really give you that in a lot of ways. It gives you some base level stuff. And we've seen a massive amount of people when they've implemented Honeycomb, that first level of auto instrumentation that they put it in, we call it the MTTWTF, which is the mean time to somebody going, what? That shouldn't be doing that. And that auto instrumentation can give you a certain level of that. It's that manual instrumentation that takes you that level above. You talk about it being complicated. Well, just think how complicated it would be for an auto instrumented system to look at your system and know what's important. So it's up to you to say, these are the important things. It's up to you to say, I'm just going to emit a span for every single one of these things, and I'm going to add these 2,000 attributes to each one of these spans because, yeah, it's important to me to know what's going on in that service. What I'm then going to do is I'm going to sample some of that data so I don't end up overloading my providers that I'm sending all of this stuff to. But it's about being able to then say, right, well, I've got 2,000 attributes to play with here. I know everything that was going on in my production system. I know that if something's going wrong, it's going to be these 5 attributes. So I'm going to put myself a bit of a monitor around those particular things to see whether they're going wrong over time.
Yeah, definitely. And yet again, this kind of like ties to what we were saying before about developers seeing their stuff through to production, because if it's the developers writing out a feature, throws it over the wall to operations and job's done, then they're not going to be motivated to write all this instrumentation into the application. But if the developer knows that if something goes wrong, they're going to have to investigate what's happened and maybe be woken up in the night and they want to find the issue as soon as possible, then there's more motivation there to actually make that instrumentation part of your definition of done and part of actually developing that feature.
Yes, that is a really important thing, is the developers being impacted by that level of visibility and that level of observability in their platform is really, really important. I have a funny story that I always tell about putting a developer as the point of contact on the support team for an entire week on rotation, where their entire job is to help out the support team. And when the support team have got questions, they're the point person. They go and sit in the room with them. And what was really interesting was a byproduct of that was the amount of visibility that was added to the product without anybody asking for it. It was, I've added this extra, at the time it was all about logs. So I've added these extra 5 log lines and I've created a little view in the application so you can view the log lines without going to the database. That level of visibility in the early days of this observability movement, people were doing that as a byproduct because they were affected by it. And when you've got an ops team that don't control that level of visibility and a dev team that aren't affected by that level of visibility, you end up with poorly supported systems. By making it the developer's job to be able to see that data and making them be impacted by it, actually what happens is you get by proxy just a massive level of visibility.
With this whole open telemetry thing, obviously it's suddenly becoming like much more popular now. Is there anything new in the pipeline and the roadmap coming up?
Absolutely. OpenTelemetry is firing on all cylinders in various different ways at the moment. So the protocol, the OpenTelemetry line protocol for logs, was finalized a few months back, and that's been implemented on all the SDKs now. There are ongoing projects around auto instrumentation for .NET. There is also a movement around doing RUM, or the idea of being able to look at an end user journey and how that becomes part of OpenTelemetry. How we start to think about sessions as a first-class citizen, for instance, because it's very different to doing HTTP request tracing. So there's a special interest group working on that specific area about how do we standardize those things. And these are all public committees. None of this is being done behind closed doors. It's not being done by specific vendors. Obviously, there's a lot of vendors that have a vested interest in making sure that these have all of the things that they currently use inside of these specifications. But like I said before, it's number 2 project on the CNCF by contributors and activity behind only Kubernetes, because I know this is now the Kubernetes podcast, so I'll mention Kubernetes again. But it's the number 2 project on the CNCF. So there is a lot of stuff going on. We're always looking for more people to get involved in helping with not just the bugs and the actual code, but also what should we be doing. We want users to come to the committees to tell us what's going wrong, to tell us how we can improve it. But there's lots and lots of little things that we're working on. We did a thing at KubeCon in Spain a few months back. We're looking at what the priorities should be for these teams to look at. Real user monitoring was a big part of that. So yeah, we absolutely want more people to get involved.
Awesome. It sounds like an exciting time to be doing this stuff. So we are fairly almost running out of time, but before we started recording, you did hold up a big, massive thing made of paper. I didn't really understand what it was.
Dead tree is what we refer to it as. Yes, it's a dead tree, the thing that our ancestors used to take off a shelf and learn things from. It's called a book.
No, sorry, I don't understand. I've understood everything so far in this episode, but now I'm confused.
So yes, a few people from Honeycomb, so George Miranda, Liz Fong-Jones, and Charity Majors have written a book about observability engineering, and it's taken a long time to be produced, but it's finally out now. And yeah, I've got a copy that I can send out as a physical, actual, tangible book for one of your listeners to be able to read and understand a lot of what the fundamental concepts are that we've been talking about today.
Fantastic. So I guess normally when we do this kind of prize draw, I normally say to the listeners, if the listeners can send out a tweet, use the hashtag unhandledexception so that I can find the tweet and mention the podcast, mention the book, mention Martin and Honeycomb. That's a lot of things to remember. I'll include links to everything in the show notes. And maybe in a week or 2, I will pick one at random. And then we'll get that shipped out.
That sounds absolutely brilliant. And I'd love to hear from any of your users' questions and stuff like that. So use the same Twitter handles and reach out.
Fantastic. So yeah, I'll include links to all the ways to contact you in the show notes, and links to the book as well, and all the stuff we've spoken about today. So shall we do dev picks?
Absolutely. So One of the things that I've been working on around the OpenTelemetry space at the moment, I've talked about us getting the developers to use traces a lot more. So one of the things that we wanted to be able to do is be able to see traces locally without having to install and do Docker Compose and bring up Jaeger and all this kind of stuff. So I've been working on an output for OpenTelemetry that outputs to the console, which has been using a package called Spectre Console, which is an amazing tool for providing really rich console outputs. And I've been really enjoying just trying to make things look really interesting in the console, because a trace is a really rich thing, to be able to see that waterfall chart. So being able to produce a table and have that be the exact width of your console window, and being able to get the width of your console window and be able to do all that is so just a really cool project. And the API is just so easy to use.
Yeah, like we had actually back in episode 14, we had Patrick talking about Spectre Console, and as you say, it's absolutely incredible. I've played around with it quite a bit, and I've even done a talk on it, where in the talk it wasn't scripted or anything, I just kind of just loaded up the documentation and tried different things in it. It was kind of like a bit free flow, and as you say, it's just so easy to use, like copy and paste from the documentation. It's like some of the best documentation I've seen, really, just to get something up so quickly and easily. So I'll include a link to that in the show notes as well. So your tool, does this come in Docker? Sorry, couldn't resist.
No.
I'm joking. No, that sounds cool as well, and I will definitely include a link to that in the show notes as well.
Awesome.
So my dev tip is I'm afraid it's completely unrelated. It's just I saw it mentioned on Twitter and it looked quite cool, and it's a website called jqplay.org, and I saw this in a tweet by Lawrence Gripper, who tweeted, "This is your friendly annual reminder that JQ Play is an awesome tool to interactively author JQ queries." Now, for those that don't know, JQ is a popular command line tool that parses JSON. It's very powerful. And the website that Lawrence tweeted about is just super useful for helping write those queries. So yeah, again, I'll link to that in the show notes.
That is absolutely awesome. I've always struggled with understanding JQ. Like literally yesterday, I was doing some stuff with bringing back some JSON and trying to filter. I think it was actually on the GitHub command line to try and filter on repo names. So understanding how to do JQ syntax has always been a little bit of a bugbear. So very much like the regex tools that you use when you can do regex in the browser. That's a really cool tool.
Yeah, my default for regex is regex 101, and that's absolutely fantastic. I used to use regex Buddy, but that's obviously a desktop tool which you got to pay for and get a license. But now you can just go to your browser and it's just like, yeah, so useful.
I would imagine it's probably a little bit better than the regex ones, because there are 4,000 different flavors of regex. All of the different tools do it in slightly different ways, which is why when you look at the browser tools, they have a drop down. It's like, which one of the 4,000 tools are you using today? But yeah, JQ is pretty awesome.
So regex 101, what does it have? Flavors. Oh, it's got 1, 2, 3, 4, 5, 6. It's only got 7, but .NET's in there. .NET's on the list. So why does .NET have its own flavor? That's ridiculous. That goes on to our conversation earlier, doesn't it?
Yes, there's. I think there's specific things in .NET around how it traces back through. I don't understand regex. I can do OpenTelemetry, I can do tracing, I can do distributed systems. Regex is where I draw the line.
I can write them. Reading them is another matter. Even ones I wrote like a week ago. It's kind of, that's one place where I would condone comments. Cool. So I normally ask at this point, where's the best place for listeners to reach out to you? But we've kind of already covered that. We'll put all the links and everything in the show notes, including Honeycomb as well, so they can check out that tooling. And with that, it's just a massive thank you for joining me. I was really looking forward to recording this, and it certainly did not disappoint. I've really enjoyed it, so thank you.
No problem at all. And thank you for having me. I really enjoyed the conversation as well.
Awesome. And so thank you for joining me on the Kubernetes podcast. Oh, that's going to stick now. I think that's already been taken somehow.
Yeah, I think that there may already be a Kubernetes podcast somewhere on the internet.
I think there's one or two, but there is one called that, which I'm a listener of. In fact, I'll link to that one in the show notes as well. Cool, and thank you everyone for listening. And a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please do help me spread the word on social media. I normally use the hashtag unhandledexception, and I can be found on Twitter at Dracan, Dracan, and my DMs are open. My blog, danclark.com, has links to all my social stuff too. And yeah, as mentioned a few times before, we will include links to all of this stuff in the show notes, which can be found on the Kubernetes podcast. The Unhandled Exception podcast.com.